In this video, we're going over the optimization homework. So we have 9 questions, and in some of them, you're going to maximize the area when the perimeter is fixed, and some questions you'll be minimizing the perimeter when the area is fixed, and there are even questions for the 3-sided fencing situation. Okay. So for the first question, they ask us to sketch 4 rectangles that has an area of 24 square meters, and the dimensions, the length and the width must be whole numbers. So I did 12 times 2, 6 by 4, 8 by 3, and 24 by 1. Obviously, these diagrams are not drawn to scale. And then in question 2, they ask me to find the perimeter of each rectangle in question 1. So the perimeter of rectangle is double the length plus double the width. So I subbed it in and I solved for the perimeter of each rectangle in question 1. And then they ask me which model or which design, you can say, gives the smallest perimeter, and the one that gives me the smallest perimeter is 6 meter by 4 meter design. And I could have told you that even without doing the calculations, because we said that the square is the perfect shape in order to minimize the perimeter. But unfortunately, if I use whole numbers for the length and the width, I can't generate a square because 24 is not a perfect square. So yeah, 6 by 4 is the closest you're going to get if you're forced to use whole numbers. So number 3, they're asking me to sketch all the rectangles that have side lengths with whole numbers and an area of 36. So basically, you need to know your factors of 36. How can you multiply to 36 using whole numbers? So 1 by 36, 2 by 18, 3 by 12, 4 by 9, 6 by 6, and those are your factors of 36. And then in 4a, it's basically like 2a. They ask you for the perimeter. They ask you for the perimeter of each of these 5 rectangles. So I did the math. I didn't write down the formula this time because it's pretty much a repetition from question 2a. But I did double the length and double the width and then found the sum. I just want to highlight the different designs. There's a clear winner and a clear loser. Okay, let's start with a clear loser. This 36 meter by 1 meter design is horrendous because the perimeter of this rectangle is 74 meters. And if you're trying to fence off this rectangle, you have to spend much more money compared to, let's say, the 6 by 6 design, the perfect square design. Okay, you go from a perimeter of 74 meters to a perimeter of 24 meters. That's a substantial difference. Okay, so that was the big idea in this lesson. By building the perfect design of the square, you can really save a lot of money because there's a huge difference between the perimeter. For 4b, they asked me which rectangle gives the minimum perimeter, and it's pretty clear that the 6 meter by 6 meter rectangle gives me the minimum perimeter. And like I said, you could have said that without doing these perimeter calculations for 4a, because we established that the perfect square design will minimize the perimeter. So of course, this is a special rectangle, it's a square. For number 5, they asked me to draw 5 rectangles with a perimeter of 20 centimeters, and the side lengths must be whole numbers. So I tried to do a length and width of 8 centimeter and 2 centimeter, 5 and 5 centimeters, 6 and 4 centimeters, 7 and 3 centimeters. So these 4 rectangles all have a perimeter of 20 centimeters. You could have drawn something else. You could have did, for example, 9 centimeter by 1 centimeter, and that will also give you a perimeter of 20 centimeters. So there are different answers you can have, or different rectangles you can draw. For 6, they asked me to find the area of each of these 4 rectangles. So if your rectangles were different, then 6a would be a little different. Anyways, the area formula for a rectangle is length times width. So 8 by 2, 5 by 5, or 5 squared, 6 by 4, 7 by 3. And then they ask me which rectangle has the largest area. And of course, we already know the answer. It's a 5 centimeter by 5 centimeter rectangle. It's that perfect square design that's going to maximize your area. Okay, so number 7, they tell me that this is the 4-sided fencing situation, okay? So you have to be very careful. You have to ask yourself, after you read the question, is it a 3-sided fencing situation or a 4-sided fencing situation? In question 7, it's all 4 sides you're fencing off. So you have 100 meters of fencing, and what's the maximum area? So what you have to do is understand with that 100 meters, with the 100 meters of fencing, you are going to build a square because that's the maximized area. So that's why you take the 100 is equal to 4s. Okay, the perimeter, which is 100, is equal to 4 times the side length, and divided both sides by 4 in order to solve for what the side length is going to be, and it's 25 meters. So if the side length is 25 meters, then what's the area for the square? So take 25 and square that value, and you'll get the maximum possible area, and it's 625 square meters. So what that's saying is that if you have 100 meters of fencing, the largest possible rectangle is going to be 625 square meter. There is no other design that's going to give you an area which is larger than that. This is the perfect one. Okay, number 8 is a 3-sided fencing situation. Okay, so they're using the hedge to act as one side of the rectangle. Okay, and that makes sense. If you want to save money, you want to make use of a wall or a hedge or something. So the 3-sided fencing situation, you need to remember the perfect design is the double square rectangle. So that means this side opposite to the hedge is twice as long as the other sides, the sides that are touching the hedge. So if this is S, this is 2S, and this is S, then the amount of fencing you're using to fence off the 3 sides of this rectangle is S plus 2S plus S. And if you collect those like terms, which these are, then it's 4S. And S plus 2S plus S must be equal to 40 meters. You have 40 meters of fencing to do the job. So 4S equals 40, divide both sides by 4 to solve for S. S is 10, and then we can find the area of this rectangle, which is S times 2S, length times width. So S times 2S, if S is 10, then 2S is 20. 10 times 20 is 200. Okay, for number 9, they basically showed me a bunch of different rectangles and asked me which one will give me a maximum area. Of course, the perimeter must be fixed. If you don't fix the perimeter, you can't ask the question. Okay, you have to compare rectangles with the same perimeter. And the one that will give you the largest area is the one that is closest to a square, or is a perfect square. And if you look at the 4 rectangles, I'll even show you. The one that is a perfect square is C. So without doing any math, without calculating the area of a rectangle A, B, C, and D, we know the rectangle C will give me the largest possible area. Okay, so that's the homework solutions for optimization, and that basically concludes the unit. Okay, so we talked about perimeter, area of basic shapes and composite shapes. We talked about finding volume, and now we talked about optimization. So whether you want to maximize the area or minimize the perimeter, You're trying to make the best of the situation.